All right, welcome to the last section of the semester, 13.4 on normal distributions. We've already seen the first page of this when I did 13.0, the introduction here, but let's go ahead and go back through this and make sure we understand this. So 13.4 is normal distributions. We're going to be covering frequency distributions and histograms, normal distributions and the empirical rule, and the standard normal distribution. So what is this doing? It's kind of putting everything together that we learned earlier about mean, median, mode. We're looking at our dispersion, how far is things, how close are things. We're also looking at, in a sense, our percentiles and our z-scores. We're definitely dealing with what's happening with our standard deviation in these cases. So we're kind of putting everything together, looking at it visually, and kind of summing up the basic statistics that we cover in this course. So the first thing that it talks about is distributions and histograms. We've already seen this problem. It says large sets of data are often displayed as grouped frequency distributions or a histogram. For instance, consider the following situation. An internet service provider, which is an ISP, has installed new computers. To estimate the new download times its subscribers will experience, the ISP surveyed 10% of the subscribers to determine the time required for each subscriber to download a particular file from an internet site. The results of the survey are summarized below. So we looked at this and we noticed that they grouped everything by 5 seconds. Again, we noticed that all the widths of the group were the same. They actually put 5 seconds in both the top one and the bottom one. So really that first one's 0 through 4, the second one's 5 through 9, the next one's 10 through 14, etc. We read about that, and I believe it says that below. Okay, so for instance here, 92 customers took between 15 and technically 19 seconds to download this time here. So that's what that chart looks like. It's just a way of grouping the data to help us visualize the data and organize the data before we graph it. And it says the graph of a frequency distribution is called a histogram. Again, a histogram provides a pictorial view of how the data are distributed. So the difference between a histogram and a bar graph is in a histogram the bars touch, and a bar graph the bars do not touch. So we're doing histograms, your bars need to touch. It says the height of each bar in the histogram indicates the subscriber's experience in total download times. So I'll just pick one random here. Let's look at right here. So this is 10 seconds. So this would be 5 to 10 seconds. So look at that bar from 5 to 10 seconds right there. If you go up to the top, 5 to 10 seconds, there were 17 of them. So this number right here, the height of this would be approximately 17, okay? So the scale on this one's pretty large, 0 to 50, 50 to 100. So it's hard to get accuracy in this one. If you were just looking at the histogram, you wouldn't be able to tell exactly what the numbers were. So the combination of having both the frequency distribution and the histogram are very nice. The histogram, again, is just a visual overall representation. So for instance, just by looking at it, I can tell that the majority of people here, I would say, took between 25 and 35 seconds, or maybe you could even say 20 to 40 seconds is where the vast majority of people are. But what I really want you to do is before we get going too far, is I want you to notice what this creates. If I connected the dots and made this a line graph instead, or a little bit of a curve, if you look at this, the cool thing about this is this creates what we're going to call the bell curve, or more specifically, we're going to call this a normal distribution. Okay, normal distribution. So that's not too important yet. I just want you to foresee what we're going to be doing in the following pages.